Good day. My name is ITTAP24.Dziubanovska. I would like to present my research on the topic assessing fake news impact on Polish political attitudes towards the Ukraine war. In the contemporary information environment, fake news has become an important factor influencing public sentiments and political beliefs. During the war in Ukraine, the issue of the impact of fake news on public opinion is particularly relevant, especially in European Union countries, where a significant amount of information pertains to events in Ukraine and Ukrainian migrants. This article is dedicated to assessing the impact of fake news on political attitudes in Poland, with a focus on using machine learning for analyzing and detecting fake news, as well as determining correlations between information campaigns and changes in public opinion. The results of this research can significantly aid in developing strategies to combat disinformation and enhance public information literacy. At the initial stage, a machine learning model was developed for detecting fake news based on a combination of text processing and classification methods. Initially, we used text vectorization with TF-IDF to transform text data into numerical features that reflect the importance of words in a document compared to other documents in the dataset. This method reduces the weight of frequently occurring words and increases the significance of rare words that may be more informative for classification. After text vectorization, numerical features were passed to multinomial naive Bayes that estimates the probability that a news item is fake or real based on statistical models. Combining these methods allowed for the creation of an effective fake news detector capable of recognizing and classifying news based on its content. For model development, three publicly available datasets from Kaggle were used containing thousands of news items labeled as fake or real. Content model effectiveness, these datasets were merged into a single integrated database, creating a more representative and diverse training dataset. Training results of the model on this integrated dataset achieved high accuracy in classifying news as fake or real. From table 1, we see that the model has high accuracy in classifying news as fake and real. The model correctly identifies 95% of fake news and 94% of real news out of all actual news. And it demonstrates high results in both accuracy and recall for classifying fake and real news, as well as good overall performance, indicating its effectiveness in detecting fake news. In the next stage, we use the pre-trained model to detect fake news using two available datasets from Kaggle, BBC News articles, covering the period from March 7, 2022 to July 3, 2024, and the Ukrainian-Russia conflict dataset, which contains information on the ongoing conflict between Ukraine and Russia since 2014. For further analysis, data from these sources were integrated into a single database. Through the combined database enabled a detailed analysis of news content and at detecting fake news, considering the specific of the war in Ukraine. This integrated news database on the Russia-Ukraine conflict and using the model trained on the training datasets, we identified 110 fake news items out of 43,811 news articles and determined their dates of appearance in the media. The constructed graph in Figure 1 clearly demonstrates the period during which there was an increase in the number of fake news items, often coinciding with significant events related to the war in Ukraine and migration flows. These peak moments may indicate targeted information campaigns aimed at manipulating public opinion. For analyzing Polish political sentiments, we use the publicly available dataset, Ukraine conflict Twitter dataset on Kaggle, which includes a large number of posts related to Ukraine and the war collected from various Twitter accounts. The data covers the period from February 27, 2022 to June 14, 2023, allowing tracking of sentiment and reactions in response to key events. Before conducting the analysis, tweets were cleaned of unstructured data and non-standard symbols and combined into a single data frame. Political sentiment analysis of Polish citizens was carried out using the textbook library, which provides a convenient interface for performing basic natural language processing tasks such as tokenization, lemmatization, part of speech tagging, and sentiment analysis. Figure 2 illustrates monthly distribution of Polish tweets, showing trends and fluctuations in activity throughout the study period. Periods of high activity may indicate significant events of information campaigns. For example, the maximum number of tweets were recorded at the beginning of Russia's full-scale invasion of Ukraine, and an increase in user interest was noted on the anniversary of the war start. This preliminary analysis forms the basis for further sentiment analysis, as the next task is to evaluate the emotional tone of tweets during these periods to understand how fluctuations in activity might affect changes in sentiment or emotional state of users. After integrating all processed data into a single data frame, we added a column indicating the amounts of each tweet's publication for convenience into the analysis. The next step was sentiment analysis using the text block algorithm to assess the emotional tone of the text. Each tweet was classified as positive, negative, or neutral based on its polarity. The data were grouped by months and sentiment categories, and proportions of each sentiment type were calculated. This allowed us to create a graph in Figure 3 that reflects changes in users' emotional sentiments over time. The visualization in the graph illustrates how the proportion of positive, negative, and neutral sentiments changes month by month, allowing us to trace sentiment trends based on Twitter activity. Additionally, we also created a workflow for positive and negative sentiments using unique words that don't overlap between categories. You can see it in Figure 4. This helps highlight key expressions that are more strongly associated with each type of sentiment. After a detailed analysis of the sentiments and tweets from Polish users, we proceed to evaluate the impact of fake news on changes in sentiment, given that our data covers the period from February 27, 2022 to June 14, 2023. We will also focus on news published during the same time frame. This will allow us to better understand whether this information influenced sentiments of Polish users during the specified period. This positive sentiment change value indicates that the average sentiment in the current month is higher than in previous months. A negative value indicates a decrease in average sentiment, and a zero value means that the average sentiment remained stable compared to the previous month. This changes in average sentiment among Polish users and the number of fake news items for each month can be visually represented in a graph in Figure 5. From Figure 5, we can see that during the period from February 2022 to June 2023, the sentiment change indicators show an overall positive trend with fluctuations. To better understand the reason for these changes, it is important to analyze the events that occurred during these months. Additionally, we calculated the change in positive and negative sentiments using a similar approach, and you can see it in Figure 6. Months with the largest change in both positive and negative sentiments often coincide with high numbers of fake news articles. The graph showing the relationship between sentiment change and the number of fake news articles in Figure 7 demonstrates increases or decreases in the number of fake news articles do not always lead to proportional change in public sentiments. The scatter plot in Figure 7 indicates a non-linear relationship between these two indicators. This complexity in the relationships suggests the need for nonlinear modeling methods for a more accurate analysis of these processes. We selected interpolation analysis and cubic spline interpolation methods for this investigation due to their ability to provide high accuracy in modeling nonlinear dependencies. Interpolation allows for the construction of functions that pass through specified points, while cubic splines in particular ensure smoothness of the curve while maintaining continuity of the first and second derivatives. The cubic spline plots you can see in figure 8. Usually it shows how the spline smoothly transitions through each control point, providing an accurate representation of change in the data. The graph is divided into several intervals, each using its own cubic equation. This allows the spline to accurately reflect different trends in the data within each interval, ensuring both precision and smoothness. The spline provides a smooth transition between these points, which is crucial for maintaining the continuity of the first and second derivatives of the function, a key property of cubic splines. The model quality assessment is presented in Table 2. The result indicates that both the data and the cubic spline model are highly accurate. With extremely low error values combined with an ideal squared value suggests that the model's predictions are virtually identical to the actual data. This level of accuracy indicates that the cubic spline is very effective for this dataset. Given that for our study, Y represents change in political sentiment among Polish social media users, and X represents the number of fake news items in the media, we will describe the equation for each interval. The results show that modeling with cubic splines allows for a detailed analysis of the dynamics of the impact of fake news on public mood changes over time. In the context of the rapid development of information technologies and the growing influence of disinformation on public attitudes, our research focuses on analyzing the impact of fake news on the political beliefs of Polish citizens in the context of the war in Ukraine. We have developed and implemented a comprehensive approach to studying this issue, integrating advanced machine learning methods for detecting fake news and a detailed analysis of the impact on public opinion, particularly through social media. Our research highlights the importance of a comprehensive approach to analyzing the impact of fake news. Combining different data processing and machine learning methods provides a detailed and holistic view of the impact of disinformation on society. Future research would focus on expanding our model to include other languages and cultural contexts, as well as integrating additional data sources to improve the accuracy and universality of the analysis. Additional understanding mechanisms through which fake news affects political attitudes can aid in educational campaigns and at combating disinformation. This includes developing educational programs and tools to enhance critical thinking among citizens. Thank you for attention.